Number of tiles and two answers for that. Order, many you want to order, and the exact many you think are on the pool. Right. So let me help you get some of those things, and we need a few diagrams and stuff for that. Let me help you with the volume, first of all. So it's a bit of a tricky shape. Let's look at it from the side again. I think I've done this diagram before. Let's look at it from the side, something like this maybe. This is the shallow end here. We have some dimensions we can put on this diagram. 1.25 meters, 1.8 meters. So we're looking at the side of the pool here. So the depth of the deep end and the shallow end, which means the difference between the deep end and the shallow end is 0.55. That means that depth here is 0.55 meters. Very good. We had some lengths here. Now this is not to scale. Perhaps your diagram could be to scale when you do it. 12 meters here is the length of the shallow end. There's a sloping bit. That's 6 meters in total horizontal distance, so this distance. And then this bit is 7 meters. So my diagram is definitely not to scale, but you can maybe allow your diagram to be slightly better. Okay, so what are we going to do here? Well, one way of getting the volume, and this is the way I'm going to show you, there are other ways of getting the volume, is to get the area of this side. And then once we have an area of the slice of a prism, so the slice of the pool, we then just multiply that area by its width. Okay, if we get this area and multiply it by the width. Now you do the same when you do the area of just a normal cuboid, like a rectangle. You get length times width, or length times height, which is this area, and then you multiply it by the third dimension to get the volume. So we're going to do the exact same thing here. We're going to do what is the surface area of this side, and we're just going to multiply it by, well, what's the width of the pool? 12.5 meters. So that's what I would recommend you do. You don't have to do that, but that's one way of doing it. So I'm going to get this area. In order to get this area, I would split it up into 3 areas. I would go, okay, this is a nice rectangular area here. That's just 1.25. This height times what? No, it's the 25 meter long pool. So we do 25 meters. That's going to give me this area, this big area here. Also, I need this area, which is 7 in length. I can see that. And 0.55 maybe in height here. So that's going to be 0.55. And this area in here is a little bit tricky to get, this little triangle here. I know that it's 6 in length and 0.55 height, so that's the perpendicular height here. So 6 times 0.55 would get me the area as if it's a rectangle, but I only want half of that. So I can do half this answer, multiply by 0.5, and that'll give this area. Now that is areas. To get a volume, I need to multiply it by something. Well, I get this answer, this answer, this answer, add them together. That'll get the area of the side of the pool. If I get the area of one side, full area, I can multiply it by the width, and that will be the volume. One slice, that's a slice, the area of the side, that's like what I call a slice. Multiply it by the width. So whatever you get when you add this together, multiply by 12.5, that will give you the volume. In what unit? Meters cubed, because we're multiplying 3 dimensions. 1, 2, 3 dimensions. We do meters cubed. Now, you can adjust this area slightly for some stuff you see. For instance, the volume will be mildly affected by things like the lane ropes were there. That might affect them because they're taking up some volume. The ladders on the side, the lights on the side might just reduce the volume slightly. So any subtractions then you can figure out. But this will give you an answer that's within the correct bounds. So just beware. So that's the volume. For the surface area, well, I've already done how to get the area of one side here. This answer, and this answer added together will be the area of one side. Now there's two sides. So if I were to draw a net diagram, which you probably should, we have the bottom of the pool here, which is 12.5 meters wide and is 25 meters long. That's the bottom of the pool. And if you're doing a net diagram, you can attach the sides to it or not. It's up to you. I would say this is like this thing is on one side and it's also on the other side. Now you could draw it a little bit better than me maybe, but I have two sides like that. Side, and this is a side. And then I have to get this area and this area of the shallow and the deep ends. And there are 5 big areas. 1, the bottom of the pool, 2 and 3, these sides, and 4 and 5, the shallow end and the deep end tiles areas. So you would need to get those 5 areas, and when I get those areas, add them together. Now, I already said how to get the area here. Multiply this, this, and this, add them together. Do the same for the other side. The bottom of the pool is going to be 12.5 times 25. That's going to be that area. So that's this area done, this area done, this area done. So you can add these 3 together, and then I need to figure out the deep and shallow end. The simplest one is to just pick the shallow end is 1.25 meters deep, and it's 12.5 meters wide. So I just multiply those 2 answers together, and that will give that area. Now I'm leaving it up to you how much you increase this number by. Why would I increase this number, the depth of the pool? Well, maybe when you went down to the pool, you may have looked at the water level, and then there may have been some area that needs to be tiled above the water level. Maybe you saw that, maybe you didn't. How much is this? Well, you'd have to add that on to the height of the pool, this height, because this height only goes up to here. That's the water depth, this height. There's a bit above, if you noticed. Okay, so that'll get this area, and then for the deep end, it's 1.8 meters deep by 12.5 meters wide, but also the 1.8 could be adjusted slightly because there was also this thing, maybe there was a bit above the water that also needs to be tiled. So they are the 5 areas. So you can check with me your answers on the volume and the surface area, and I'll tell you whether they're in the correct bounds or not. For the number of tiles, something that's quite important is this area. Well, there's a couple ways you can do it. You do like a counting method. I think the easiest way to do it is get the total area and divide it by the area of one tile. I think that's probably the easiest way to get the number of tiles instead of counting. So the total area you will have got already, this answer, all these areas added together. Once I get that, I divide it by the area of one tile. Now, what is the area of one tile? Did anyone work it out? Felix?
I'm pretty sure it's 10 centimeters height and 5 centimeters.
I think it's like, yeah, it's around 10 centimeters this way, 20 centimeters that way. Now, my problem here is around, so these are my very rough measurements. You can adjust if you found tiles that are different. Maybe it's 9 centimeters, 19 centimeters. The total area is in meters cubed, and if I do this, my area of one tile is going to be in centimeters cubed, or sorry, squared. Is that going to be a problem, or is that okay? Like if I multiply these two together to get the area, it's 200 centimeters squared. Is that the same as 2 meters squared? It is definitely not. 2 meters squared is bigger than this whiteboard. A centimeter squared is like the squares on your workbook. That's a centimeter squared. This is about 1.5 meters squared, so 1.5. So they're not the same thing. So what we need to do is we need to convert. I would recommend converting this to meters first and then multiplying. So you get the area of one tile is quite small, 0.02 meters squared. That'd probably be what I would do, 0.02 meters squared for the area of one tile. Or you can divide this by 100 twice for each dimension. And that is the area.